All right. Hello, everyone. Welcome back to the Augmented Intelligence Workshop. As most of you know, it's a place where we discuss technological and social ways in which human cognition is augmented. And today we'll have two speakers which fall onto the more of a social line of the workshop theme. So the first speaker will be Barbara Mellers from University of Pennsylvania, and she'll be talking about some really impressive empirical studies looking at the effects of social interaction on the wisdom of the crowd effect. And the first speaker will be Robert Goldstone from Indiana University, and he'll be talking about experimental paradigms and computational models aimed to shed light on the emergence of specialization in groups. So without further ado, let's welcome our first speaker, Barbara.
Thank you. So, the slides okay? Great. All right. So I'm happy to have the chance to talk to you about my research today, and I'm very grateful that you'll put up with another Zoom talk. Okay, this is work that I've done with Ike Silver, who is a newly minted marketing professor at Northwestern, and Phil Tetlock, a faculty member at Penn, and my husband. Okay, wise conversations are really one of the great joys of life, and I'm going to talk about a specific type of conversation, one in which a group must make a prediction or an estimate of an unknown quantity. So these are judgments of uncertainty. And all right, why? Okay. Examples include estimating the number of metric tons, of CO2 that the US will emit next year, or the number of worldwide COVID cases that occurred last month, or the number of square miles left in the Amazon rainforest. As I'm sure you all know, a robust method for tackling such problems is to elicit independent answers from many people and compute the average. For groups large and, yeah.
Sorry, I just wanted to tell you that I don't think you are progressing on the slides, if that is what you wanted.
Oh, so what slide do you see?
The very first one.
Okay. Why do I see? Okay, all right. Let me see if I can take care of that. Hold on. All right, yes, this was my examples of different estimation problems. Okay, and now do you see the people? The wisdom of crowd?
Yes.
Okay, wonderful. Okay, so as I'm sure you know, the robust method for tackling these kinds of problems is to elicit independent answers from many people and get the mean. And we know from lots of studies and demonstrations that the average of independent estimates frequently outperforms individual estimates and sometimes even the very best estimate. So this is known as the wisdom of crowds. In reality, however, groups often don't work that way. They often want to collaborate. They are not independent. And they value discussion and believe it improves their estimates. So this means that a central tenet of crowd wisdom, the independence of estimates, often breaks down. So our research addresses the question of when is the average of judgments after group discussion more accurate than the average of independent judgments without discussion. I'll give you the punchline now. Groups benefit from discussion when they're collectively calibrated in their confidence. So let's take an example. Imagine a small group of 4 people. What I'm saying is that groups will benefit from discussion when you see the situation on the left. That is, more knowledgeable, more accurate members of a group are also relatively more confident, and less knowledgeable members of the group are relatively less confident. The picture on the right side with poor calibration illustrates the case in which group conversation is less likely to be effective. Okay, now we're all familiar with individual confidence calibration, and we know that's the correspondence between a person's confidence and their accuracy over a large set of events. People are individually poorly calibrated, and they're usually overconfident. Now, here what I'm saying is that groups can vary in their collective confidence calibration, defined by the rank order correlation between accuracy and confidence among the group members. It's very simple. When the accurate members are the most confident, the groups will benefit from discussion. And when the most accurate members are the least confident, as on the right, groups will not benefit from discussion. Okay, group discussion can be costly or beneficial. Costs include biases, such as overweighting shared information, overlooking unique information. Groups can engage in bullying, herding, and groupthink. And from a statistical perspective, correlated errors, judgment errors, when correlated, are less likely to cancel out. The benefits from group discussion are that groups can share information, they can foster engagement, they can allow members to articulate their rationales, their ideas, and their statistical benefits are that groups can rein in outliers and correct individual errors. Now, our studies were done before COVID. We asked students at Penn to come into the Wharton Behavioral Lab and do the experiment. So the first thing we did was to take away their cell phones, which drove some of them crazy. Then we sat them down in front of computers in individual cubicles. We assigned them to groups of about 4 or 5 people sitting nearby. We gave them a few minutes to say hello. Then we asked them an estimation question, such as, what's the population of Canada? They made an independent estimate and rated their confidence. Then they turned their chairs around and discussed the question for 3 minutes with other group members. Then they turned their chairs back and made a second independent estimate, rated their confidence, and said whether the discussion helped them become more accurate. So we predicted that the correlation between accuracy and judged confidence prior to discussion would predict the effects of group interaction. When the correlation's positive, that's a good thing, and the groups are less likely to, or more likely to benefit from the interaction. When the correlation's negative, groups are less likely to benefit from the information. They're likely to listen to the less informed people, and the discussion will go off the rails. So why should collective confidence calibration predict the effects of group interaction? Those who behave more confidently are often judged as more knowledgeable, and they have a greater effect on group interaction or group decisions. So the tendency to herd toward the people who are confident is commonplace, but it doesn't necessarily lead to better answers. Listening to the confident people will benefit groups when the confident members are also the most knowledgeable members of the group. So we conducted 2 large laboratory studies. Study 1 explored the relationship between pre-discussion calibration, confidence calibration, and group improvement. The second did the same, but also tested a mediator of that relationship, which is the ability to identify the most accurate members of the group. In other words, does the ability to identify the most accurate members mediate the relationship between confidence and confidence calibration and group improvement? The types of questions we asked were, as I gave you one example, what's the population of Canada, which is 40 million if you want to know. Tanzania, Uzbekistan, historical dates, such as the invention of the printing press, the Flushing, when the Flushing toilet was invented, or the first modern Olympics. Study 2 also included questions about distances as the crow flies, or between such world cities such as Reykjavik and Nairobi, stock prices 1 week in advance, and additional questions. So in study 2, we also asked, after each question, we asked participants to select the group member who provided the most accurate and useful judgment during the discussion. We incentivized them in study 2 with $5 Amazon gift cards if they came within some prescribed distance of the correct answer. And we reduce within group competition by saying, you know, everybody can get as many Amazon cards as they can. There's not a fixed pot here. Now, we're going to define our dependent variable of group improvement in 2 different ways. And I'm just saying this to tell you that the effects generalized. We find the same outcomes, the same effects, regardless of the dependent variable. The first one is a binary measure of group improvement. And that is to say, is the mean of the estimates after discussion more accurate than the mean of the estimates before discussion? If yes, we code that as 1, otherwise 0. So it's the first one. The second one is the proportion of individual group members who improved. So this will be a number between 0 and 1, inclusive, and yeah, if you improved 1, otherwise 0. Okay, so yes, what actually happened? Now I'm going to start with something that isn't related to what I've discussed so far in the introduction, but it was just so interesting that and we're studying it now. The vast majority of individuals were overly confident and believed that discussion improved their estimates. And this was the case for virtually every single person in every single conversation. You know, you can make questions harder or easier, and increase or decrease the likelihood of discussions improving accuracy. With our particular questions, 60% of about 1,000 discussions improved accuracy. But 95% of individuals believe that discussions improve their accuracy and improve the overall estimate. The second effect at the individual level is that post-discussion estimates were more tightly clustered, which is not at all surprising in the least. Okay, so what about the question level? Are questions associated with higher calibration scores also more likely to show group improvement? So each point in this graph is a question, and what you see here is that the answer is yes, and the correlation is 0.61. It's a pretty tight correlation between rate of improvement and collective confidence calibration. Okay, we used logistic regressions to test the effects of calibration on group improvement. We had random effects for groups, individual groups, and questions, fixed effects for question type, distance, stock prices, and group size, and a fixed effect for calibration. And we found significant results in study 1, in study 2, and in the combination. There was a 26% increase in the odds of improvement per standard deviation increase in collective calibration. Okay, our proposed mediator of collective calibration was the enhanced ability of groups to identify their most accurate and knowledgeable members. And we measured this in study 2 by asking people to report after a discussion which person on their team provided the most accurate input. And we calculated the proportion of people who answered correctly. If better calibration was associated with the ability to identify accuracy, we should find positive correlations between calibration and the proportion of group members who recognize the most accurate teammate. That's exactly what we found. So to test our mediator variable, we computed the relationship between rate of improvement, rate of group improvement, and confidence calibration, and it was significant. But when we added the mediator, the ability to identify accurate peers, the relationship between confidence calibration and rate of improvement was insignificant. So what did we learn? Well, first, groups are overly optimistic about the benefits of discussion, regardless of judgmental accuracy. And second, we can predict the effectiveness of group discussion if we know the group's pre-discussion collective calibration. Collective confidence calibration predicts group improvement because it reflects the extent to which confidence tracks accuracy, or that is to say, the extent to which the most accurate people are also the most confident. Now, I should mention that our results demonstrate a correlation, not a causal link, but there are reasons to believe that collective calibration plays a causal role. Why? Well, first, calibration was measured prior to improvement, ruling out reverse causality. Second, empirical relationships were robust across questions, incentives, metrics of improvement and levels of analysis. And third, it's difficult to identify another variable that might explain these patterns. We controlled for a host of additional factors, but still find a stable link between collective confidence calibration and group improvement. So on the practical side now, how can we make conversations wiser? How can we make groups better collectively calibrated? Well, first, I think we need to be skeptical of discussions. Many people love discussions. And the simple fact is that they don't necessarily improve accuracy. Second, we should keep records of confidence and accuracy of individuals and groups. And third, we should design interventions to teach people to be collectively calibrated, especially when groups are reoccur and interact frequently. So researchers have tested a host of procedures to improve individual calibration, asking people to give rationales, asking them to generate counter arguments, giving base rates for events, making them more accountable, providing feedback. We need ways to make groups collectively calibrated, and we've tried a number of different ways ourselves. It's incredibly difficult. It's much harder than you might expect. So to conclude, people are poorly calibrated and overly confident in their individual abilities. And we show that collective confidence calibration is also important. Why? Because it's a useful tool for predicting whether groups should interact or work independently. Knowing what we know and knowing what we don't know relative to others is a good barometer of the wisdom or folly of interacting crowds. Thank you.
Thank you, Barbara, for this very inspirational talk. I would like to invite people to ask questions specific to this talk, and I see a lot of discussion in the chat already. So if anyone wants to speak up, please go ahead. But I could start with my question, even though I have many. So the question I had was about what seems to be unique here in the discussion that couldn't be achieved by just weighting participants' judgments based on their confidence. So I was wondering, do you expect to obtain similar results if individuals did not discuss anything at all, but the original judgments were just weighted based on their confidence, and then in some cases when the confidence actually reflects their knowledge, you would obtain better estimates by this. So that is.
Okay, I think what you're saying, and correct me if I'm wrong, you're saying would a averaging model with weights based on confidence prior to discussion predict judgments just as well as maybe average estimates after discussion or weighted confidence judgments after discussion? And the answer is no, they don't. The group interaction, sharing information, discussing why you believe something is true or not true, benefits the group. And I think in terms of increasing signal, it could also be decreasing noise, but that's not as effective. It's a really good question, but it's not as effective as the group discussion.
Great. We have David, and then Jim, and then Celia and Ishan.
David, I can't hear you. I think you're muted. Do you hear David?
Still muted.
Okay, it seems like he wants some time, and we would switch to Jim, and then hopefully we'll get back to David.
Okay, well, thank you. This is fascinating work. And just to follow up on my momentary comment in the chat, seems very important for society too, right? I think one of the problems with our society coming to good public policy decisions, say regarding science, COVID, what have you, is partly due to the breakdown in being able to identify expertise. As you know, increasing proportions of the public reject, say, for example, scientific expertise as a credential for accuracy. Seems like we're in this a poorly calibrated situation. Do you have any comment on that?
I completely agree. The question of how to measure expertise is a very difficult one, and in many respects distinct from the question of whether and when group discussion will benefit groups who are attempting to make an accurate prediction or estimate. But I believe you're right that it's very important.
So I guess the only follow-up is that then maybe we need to figure out a way to design better conversations in society. But anyway, okay, thank you.
By the way, can you hear me now?
Yes.
Okay, great. Thank you very much. So I have a suggestion for an experimental manipulation that would test your hypothesis directly. Namely, perform a set of preliminary tests that allow people to measure individual knowledge and calibration, and then use this course to create groups, create by design groups where you can guarantee that there is a rank good positive correlation between confidence and knowledge, and other control groups where they are at random. And you would expect to see, based on your hypothesis, that the first type of groups would benefit from discussion and the latter don't. So that's my first point.
Excellent idea. I completely agree, David. That's clever.
So I have a comment as to why I think people are individually so confident in the impact of discussion. And I believe because many of them get the wrong feedback from discussion. Many of them come in and listen, they don't learn anything new, but they get other people who share their views. You know, they get reinforced for their own prior beliefs, correct or incorrect. And therefore, if other people share your view, you think, you are accurate or more accurate. So I think there may be a point in which people are confusing what they have learned and how confident they are, or how much support they see from their independent opinions. And therefore, this may cause them to overestimate the impact of conversation.
Agree. We just don't get feedback much of the time. And if to the extent that we live in echo chambers and talk to people who agree with us, that's definitely going to occur. Yeah. Good point. And that's a great idea that you had about manipulating collective confidence calibration. Thank you.
Your presentation was so beautifully clear, and the topic is clearly so important. My question is just about that tantalizing remark at the end. You said that, it's really important to design interventions to promote collective calibration, but that it's really difficult. I wonder if you could just say a little more about what's been tried and why you think it's so hard.
Well, what we've done is to give some groups tips, simple tips for how to have a good conversation. And for example, one is to make sure you get, I know these sound ridiculously simple, but groups don't do this. Be sure you get estimates of accuracy from every individual in the group, and base your opinion on their or change in their direction to the extent that you you buy the reasons for their estimate. So people should be giving their estimates and the reasons for them, and you ought to be basing your changes in your own estimate according to how valid the individual reasons are. And those have not worked. I'm really surprised, but you know, it happens. So we're working on. Stay tuned is the answer.
That's kind of the reasonable route, isn't it? Encouraging people to be reasonable. What if you were more flat-footed and just, you know, gave people information trial by trial? You know, this person was this amount confident and they were this amount accurate, as it were, and you gave them that information over a series of trials. Is there any sign that that makes people better?
That would probably make people better. Yes, we have not done that, but that is the kind of thing that I think businesses should be doing when they have groups that frequently interact, and there's an opportunity for people to learn individual members' skills. So, you know, when I talk about X, you shouldn't listen to me, but when I talk about Y, you should, and so forth. Yes, that's important, and we're still working on it. Thank you.
Thank you.
Great. Ishan?
This talk was really interesting. I think there's so many questions about what kind of interaction and so on. So one question that I think I'd pick up on is, how do you think this, what kind of implications do you think this will have for interactions between groups of hundreds of thousands of people on, say, social media, where we're interacting through comment sections? And if this is not a good means and you don't have estimates of other people's accuracy and confidence, then what are the consequences of us in terms of collective behavior?
Well, in an ideal world, wouldn't it be interesting to have some measure of people's expertise on a topic associated with the information they're providing about that topic? That way you could better evaluate it. Don't ask me how that would be done, but that's an example of what would be interesting in an ideal world.
That's really interesting. Thank you.
Seems like we have time for Stephen's question.
Oh, great. Thanks. Thanks, Barbara. Great talk. First, a comment and then a question. A comment on David's comment, which is, you know, it may be that feedback from others mostly reinforces your own beliefs, but I suspect what often happens in discussion is that people say things that are just wrong, but you don't know they're wrong. So you think you're getting information when in fact you're not. And that may be why people think that discussion helps. My question for you is, how much of this effect do you think depends on the fact that you only gave people 3 minutes for discussion? Like, presumably with more time, people would learn, at least to some extent, how to separate someone's confidence from their knowledge, right? Like, we all know people who aren't confident, but we realize they're very knowledgeable after a while. And presumably conversation aids that distinction.
Yeah. Okay, well, I think that in a case like this, where you have just a little bit of time to discuss, you should do something along the lines of what usually happens. Go around the group and pull out estimates and find the rationales behind them. But really, what I think would work much better with more time would be to have group interaction be centered around some sort of adversarial collaboration, where there are clearly stated positions on different, let's say prediction of whether the Russian-Ukrainian war will end by date X. There could be positions stated out, and people could present their best arguments for their position, and that could be discussed in a sort of adversarial fashion. We don't have time for that. but I think you can even pull out tidbits about how to formulate good conversations, even when the conversations aren't that rich and the time is extremely short.
Okay, thank you.
Great. Now would be a good time to switch to Rob's talk, and then we'll have time to discuss both Rob's talk and Barbara's talk and their overlap.
Okay. Okay, so let me stop sharing. Or can you, yeah, okay.
I'm good, thanks. Great. So humans are routinely forming groups to achieve important goals that nobody in the group can achieve on their own, such as inventing a vaccine against the coronavirus or dropping basketballs into well-defended baskets. And over the years, our lab has been particularly interested in the kinds of coordination that groups achieve when no member is able to communicate directly verbally with another. So when most people think about group coordination, they're imagining situations on the left, such as when soldiers are marching in lockstep, theatergoers are applauding in unison, or band members are perfectly synchronizing their dance moves. And synchronization is one mechanism for facilitating coordination, but social life is rife with examples on the right where groups are working better together because the group members are doing different things, such as one player feeding the ball to another player who will shoot a basket, the members of a surgical team that are playing complementary roles, such as cutting and stitching, intubation, and watching the monitors go beep. Or at a macroscopic level, you have the entire division of an economy into specialized occupations. I'm not going to talk about how whole economies are organized because it's messy, it's really complicated. I'm not an economist, I'm a humble cognitive psychologist, but I would like to talk about 3 projects from our lab that provide relatively clean, controlled, minimal paradigms for understanding how group members self-organize themselves into distinct roles in order to solve group-level problems. The first project is somewhat obscurely called Group Binary Search, and it's based on a game that you used to play with your grandmother, where she would think up a random number between 1 and 100. You make successive guesses, and she provides feedback after each guess about whether your guess was too low, too high, or exactly right. And so 10-year-olds find this game pretty easy, and the game becomes downright trivial if your grandmother tells you exactly how much you're too high or too low by. So if you guess 50 and your grandmother says you're too low by 29, then you know the answer is 79 on the next trial. So in our collective version of the same game, a computer is going to replace the grandmother, alas, and it's going to think about a mystery number between 1 and 100. Group sizes range from 2 to 20 players, and every member guesses a number between 1 and 100. The computer is going to add up all of those guesses together, and it's going to compare the sum to the mystery number, and it's going to give exact feedback to every group member, the same feedback, about how much the group was off by. So, for example, if the members of a 4-person group guessed the numbers 20, 40, 20, and 20, and the computer was thinking of the number 88, then it would be telling all of the people in the group that they were too high by 12. And so reacting to this feedback on the next round, guesses may all be smaller numbers like 10, 10, 16, 17. But now they're going to be told that they've gone too far, and now they're too low by 35. So this game is harder than the single player version because the players don't know how each other are going to be responding to the feedback. Okay, this the part where I could actually try giving the online version of this. So if you look in the chat window and you follow the link, you can play an interactive version of this. I'll be pleasantly surprised if it works, but look for the information about how to access it, and maybe somebody in the chat window can tell me how well the group is doing and whether you actually find the answer. So using this paradigm, we can find, first off, that small groups do better than large groups. And that makes sense because it's hard to coordinate the larger group. As we all know from trying to go to dinner with like a 15-person group back in the before times when we used to have workshops that didn't meet by Zoom. There are other things that do help large groups to coordinate. Namely, members of groups, when they adopt different roles over time based upon how much they react to the feedback which is given by the computer. So the plot on the left here shows the individual guesses for one particular random game that I picked. You'll see it took them about 14 rounds to get the right answer. And you'll see that there's some individuals that pretty much kept their same guess from round to round, no matter what the group was doing, whether they were too high or too low. But then there's other individuals that reacted strongly to the round by round feedback. So we can measure how well a player's reacting to the feedback by how much they increased their guesses when the group was too low, decreased their guesses when the group was too high. And so if we use this measure, we find that players adopted different roles in two different senses. The variability of their reactivity to the feedback within a player is going to be decreasing as the experiment goes on, and the variability across players is going to be increasing over time. One becomes not reactive, another becomes reactive. And to me, this gives a pretty good gloss on what we mean by adaptive roles within a group, consistency of the behavior within the people, and differentiation of behavior across the people. And furthermore, we find that the extent to which the individuals in a group differentiate themselves into role predicts how quickly the group will reach the mystery number, particularly so for larger groups. And thanks for, yeah, okay, I'll get at the end how well people did. So the formal computational model that we developed that performed best and actually performed most like our human participants was one where the agents decreased their reactivity whenever the computer supplied feedback changed its direction from too high to too low, and also trying to differentiate themselves from others. Okay. So that's the first paradigm. So in a second paradigm that Robert Hawkins and I call the Battle of the X's, two players are tasked with moving their avatars to one of two targets that offer different reward amounts. So in this example, both players would prefer 4 cents over 1 cent, but there's a second condition that we place subjects under, which is that if both players end up moving to the same target, then neither player gets any reward for that trial. So half of the dyads played under a dynamic condition in which they can see each other's step-by-step movements, and they can change their course at any time before one of them reaches a target. And the other half of the dyads play in a ballistic condition. And in the ballistic condition, each of the players first selects a target, and only after the targets are selected do each of them see the step-by-step movements of the other one. Okay. Also, half of the dyads played with relatively high stakes of 4 cents versus 1 cent, and the other half played in relatively lower stakes of 2 versus 1. So the groups played about 60 rounds in all, and sometimes the dyads would stumble across clever strategies, such as turn taking. So even though we never mentioned this as a possibility. In this case, like the red player is going for the larger payoff on all of the odd trials, and the blue player is moving to the larger payoff on all of the even trials. Okay, so that's the setup. And here is one way of assessing the performance of the dyads. So this turn-taking behavior that we mentioned is a good solution in three senses that have been articulated in game theory. The solution is efficient, which is defined as the players getting high payoffs. The solution is fair in terms of both players getting similar amounts of money. And the solution is stable, defined as how predictable in an information theoretic sense are the two players' choices from round to round. So as shown in these results, player solutions tend to be more efficient and more fair when they can see each other's step-by-step movements than when they can't. And an implication of these results is that giving the members in a group more information about what each person in the group is currently thinking about doing can help the group achieve well-coordinated, fair, and happy solutions. And this, I think, is very much in line with where Barbara Mellers was heading in her talk, where she talks about also giving more information about the players' calibration levels. In terms of developing stable solutions, we see a strong interaction between payoffs and movement types. When the stakes were low, the players in the dynamic condition simply relied on moment-to-moment visual information to figure out who should be getting the larger payoff on any given round. And so for the low stakes situation, the dynamic condition is actually more surprising, less stable than the ballistic condition. However, this exactly reverses in the higher stakes condition. So our interpretation of this is that when the stakes are high, then the dynamic condition developed significantly more stable solutions than the ballistic condition, because for particularly contentious, high-stakes situations, it's useful for the players to develop strong norms, such as turn-taking, to help them coordinate and avoid conflict. And this moment-by-moment information that they're getting in the dynamic condition allows the player positions to create these norms. Okay, so that is the second of these three paradigms I wanted to talk about. And in the third coordination paradigm, Edgar, Andre Lotero, and I came up with a task in which two players are simultaneously trying to guess whether a unicorn is present or absent somewhere on an 8x8 grid of tiles. And players can turn over a tile to see if the unicorn is underneath it, and the players get points for correctly guessing whether the unicorn is present or absent. But each time both players turn over the same tile, points are deducted, so the players will score better if they turn over complementary sets of tiles. The players can see what each other's current guesses about whether the unicorn is present or absent, and they also see when players select an overlapping tile, they're shown blue to both players. So players fairly often, about 57% of the time, they learn to effectively coordinate with each other. And this is almost always achieved by the players settling on complementary focal regions, such as the ones shown here in red. For example, one player would turn over all of the left tiles, where another player would turn over the right tiles, or one would turn over the top tiles, where the other turns over the bottom tiles, or the inside versus the outside. So these are all efficient ways of creating complementary focal regions to use for uncovering the tiles. Okay, so here are the results from the experiments that go some ways towards suggesting the ways in which people are able to achieve these complementary trials. One thing that we find is a kind of a continuous valued version of a win, stay, lose, shift strategy, which is if the score from the previous trial is relatively high, then you simply keep the strategy. So on the x-axis, we have the score on the previous round, and on the y-axis, we have what is the consistency with which you turned over tiles on trial n-1 and n. And the other kind of strategy that we're seeing is that if a player chooses a strategy which is close to one of these focal regions, like top or left or outside, then they tend to stubbornly keep it. So on the x-axis, we have the similarity with respect to one of these focal regions on the previous round. And again, that's a positive predictor of your consistency on the next round. Okay, so in moving towards a synthesis between these three different paradigms, we've been proposing in an under review manuscript what we call this CARMI framework for the emergence of specialized groups in interacting dyads or n-player groups. And each of the letters stands for a particular factor which we think is involved. And the C factor is the communication of intentions, plans, and proposals for dividing labor. And I guess I'd say the most obvious way to establish roles is for agents to explicitly communicate with each other. I say, I'll cover LeBron James, you cover Stephen Curry, we'll do just fine, right? And communication is notable in our three paradigms because of its complete absence. Right? We purposefully did not allow our group members to communicate because it would have made coordination trivially easy. A stands for adaptation to feedback from either the computer or the world telling you how well you're doing, and also feedback about what other individuals are doing in your group. R stands for repulsion, and this captures the unique aspect of coordination via role specialization as opposed to synchronization. So as agents receive feedback and track other group members' actions, they tend to be repulsed away from their partner strategies. So they adjust their strategy towards what they perceive to be the complementary strategy compared to their partners. M stands for multi-level plans, capturing the important idea that role specialization is unfolding across multiple temporal and spatial scales, often spanning orders of magnitude. So at the long time scale of an entire lifetime, role specialization is tantamount to the development of professional expertise. And at a short time scale, teams may need to spontaneously organize themselves into ad hoc roles, such as when doctors in emergency triage units are spontaneously assigning themselves to patients or to wards. And crucially, these different timescales interpenetrate and influence each other. And finally, the I of CARMI stands for modeling partners' intentions. So group members develop models of their partners' intentions and goals and use these in order to shape their expectations and their behavior. Okay, so with CARMI in mind, I'd like to emphasize some general cross-paradigm commonalities that we're observing. And the first obvious commonality is that good group coordination oftentimes is involving not members all doing the same thing at the same time, but developing specialized roles. So some players reacting to feedback while other players stay put. one player going for 1 cent when the other goes for 4 cents, one player uncovering the top tiles when the other player goes for the bottom tiles. And this leads to a second generalization, which is successful division of labor is facilitated by different partners or different players playing specialized roles. And our formalized notion of a role has two components: the player being consistent in their own behavior and being differentiated from the other players. So players are turning themselves into what you might think of as sort of modules in a larger system. And this leads to the final point, which is that in cognitive science, we oftentimes think of modules as being stupid, automatic, and informationally encapsulated. But the modules, or cogs, if you will, that human players are turning themselves into are, in this case, very strategically constructed. The computational models that fit the human behavior the best, and also the ones that do the best for the task, tend to have mechanisms that strategically differentiate a player's behavior from others to fit well with what the player thinks the other player is trying to do. And so in some cases, there probably is competition between different levels of systems. And the more the individual selfishly cares about themselves, the less coherent the group is going to be. But at least in the three paradigms I covered, the opposite seems to be true. And one of the things that smart people do is they form smart groups. Okay, great. So that's my presentation. Marina?
Yes, thank you, Rob. This was excellent. And I would like to open this up for discussion as well. And I could start with one question as well. And people who have questions, just raise your hand. So I was wondering about the no communication part of your experimental paradigms. And I was wondering how much of a change would you expect in the Carmi framework and different importances of all these different aspects of adaptation to feedback or some other parts when communication is actually present. So do you expect that people might become, for example, less sensitive to all these other parts when they communicate? And they
Absolutely. So, right. So great question. So communication in all three of our paradigms is going to help a lot. It's doing the lion's share of coordination in many real world situations. So I do believe that part of the reason for communication is to avoid the uncertainty that you get if you're going to be trying to dynamically respond to other people who, might have a shaky hand and or noise, or they might have momentary selfishness. So, right. So I think that is a big reason for communication. It's interesting in a game theoretic perspective, because oftentimes communication is viewed as cheap talk. It's easy to say, oh yeah, I'm going to cooperate on the next trial, and just lie and defect. And so I think in some group theory perspectives, it's surprising that communication is as powerful as it is. But I think the truth about actual human systems is that it is actually extremely powerful. And then even in some ways of thinking about it, it would just be cheap talk, and you wouldn't have to do what you said you were going to do. There's many societal, infrastructural mechanisms to make it so that the talk has teeth to it. And even when there aren't those kinds of infrastructures in place, people seem to act like there are, and so they live to their world. And there's many norms about doing what you said you were going to do that probably in an informal way make those so that we don't have to rely on dynamic interaction like we were talking about in our lab experiments.
Yeah, thank you. And maybe just to follow up on this, can you maybe think of ways when the discussion would be harmful for group performance in some situations? So for example, as you said, when people discuss things in advance, they might have a tendency to stick to the roles, the strategies they discussed, even if they seem to not be working. So would this be one example where communication does not really help?
Absolutely. Yeah. So that's right. So that was the first one I was going to say. It's easy, like in a basketball game situation, to say I'm going to cover LeBron James, but it turns out that he's just a little too much for me to handle. And so I could use some help from Stephen Curry to help me cover LeBron James. So in many situations, in adversarial or sports competitions, there's efforts from the other side to make it so that the previous communications, the previous plans that you created are not going to be adequate. So I do believe that both are required. So yeah, great communication is great. To have a plan going into the coordination theater that you're in, but in many situations, you're also going to have to supplement it by the kind of dynamic coordination that we were talking about and adaptive role specialization. And that's, in a restaurant context where everybody is ordering the salmon, you're going to have to readjust your roles online so that you get enough salmons being prepared. Yeah, so great point. And the other thing that comes to mind is what Barbara was talking about, and communication might not be helpful if some people are far more persuasive than the actual reasoning behind their ideas would give credence for. So communication could be problematic if people are not well calibrated and if people are convincing in ways that is not going to be revealing of the actual weight behind their ideas. Ishan or Celia or?
I'll go for it. Thanks, Rob. This was a great talk. One question that I had was, how complex are people's models of other people's intentions? Are these like simple heuristic sort of models? Because a lot of times we've sort of thought that humans have sort of simple intuitive models, right? But when we are modeling other people's behavior, do they also say model emotion and this and that? So can we get a sense of just how complicated and refined these models are?
Yeah, that's a great question. For our situations, these models could be rather simple. So we assume, like Schelling assumed, that there are these focal attractors that everybody knows, like top versus down is just something that is on everybody's mind. And so the level of intention reading required for our experiments is really not very much. And for like the group binary search, that intention reading is just, I'm thinking everybody is going to overreact to the feedback, so I'm going to go in the opposite direction. And maybe some people did that in the game that you just played, maybe. But the intention reading could be far more elaborate than that. And I think there's great work, partially from Robert Hawkins, my collaborator on the second project, saying that those intentions are fairly sophisticated in terms of inferring mental states in the partners. On the other hand, there's also evidence of failures, situations where people assume that somebody is going to have knowledge that they know from their perspective, but they should also know that the other person doesn't know it. I'm thinking of like Boaz Kazar's work, where people will give instructions about how to find an object, where if the apparatus is set up so that they give instructions involving landmarks that they should know that the other person doesn't see, and yet they still sometimes they give those instructions, suggesting that they don't have a perfect internal model of what the other person has at their availability. So it's an experimental question, but I think ours are on the low end side of intention reading.
That's really interesting. Thank you so much.
Ami and then Celia.
Hey everybody, I'll just turn my camera on. Hi everybody, thank you very much. These were two excellent talks, really superb, and I have lots of questions on both of them, but I thought I'll maybe just choose one and ask you, Rob, about the nature of synchronization, or perhaps lack of, in scenarios where people can't just go their independent way, but rather need to pull together a collective effort in order to surpass some critical threshold. And just to illustrate this, I always fall back to building the pyramids. So you can imagine that in building the pyramids, no single individual can surpass the necessary amount of labor to perhaps carry over a single piece of rock, right? And so if you had to let people individually negotiate the different challenges, there would be no pyramid erected. And so instead, they must collectively pull their effort together in only a specific location. And I suppose, Rob, you can probably make the analogy to your unicorn game by saying that in this kind of setup, they would have to both be concentrated on a specific spatial location. And so perhaps, how do you see the difference between those cases whereby perhaps one set of tasks or scenarios allows people to differentiate or diverge their effort, thereby leading to some collecting advantage, whereas in others, they simply cannot do this because there is not a linear progression of just accumulating labor, but rather the need to aggregate that critical mass?
Yeah, that's a great question. It goes beyond some of the work that I was presenting just now because, well, for the dyads, we only have two. For the group binary search, we do have more than two, but I think you really want to look towards games more like a stag hunt game, to look at critical mass, where you say, look, I can hunt a rabbit on my own, okay, but I'm going to need a critical mass if I want to hunt a stag. And we have looked at that kind of situation. Seth Fry and I have a multiplayer stag hunt games where you need to have everybody commit to hunting or going for a big resource in order for everybody to get a portion of that resource. And you definitely get those critical mass phenomena. One of the interesting things about those phenomena is that you get a huge advantage when there's a high endemic rate of people going for the stag rather than the rabbit. And that's a huge social issue for places where there's relatively low cooperation rates. There's nothing that anybody can do acting as a solo, acting as a maverick in those worlds, because you don't have a high enough endemic rate of cooperation to make it worth anybody's while to cooperate. And so I think there can be social level analyses about what are the groups that are on the brink to being able to cooperate if you push them over just a little bit more to a different regime. And so I think you get those kind of effects. One thing that helps a lot is to have different levels of threshold for cooperation. If everybody needs a level of 80 and you're at 10, then that probably is not going to cut it. But if people have different levels of cooperation, then you can build your way up to cooperation. So that's another situation in which it's better when people are not all synchronized, yoked, doing exactly the same thing with the same threshold, but where you want to have variability in the threshold for cooperation in order to potentially ramp your way up to this critical level. Great.
I'd like to kind of take Ishan's question a stage further to do with kind of cognitive requirements. And I'm remembering that I think it was Skinner, certainly subsequent behavior analysts, have got pigeons learning to cooperate using complementary roles in operating a fairly elaborate kind of food dispenser. Now, presumably, they don't have much of an overview of how, as it were, the pigeon machine works, of what they're doing in relation to what others are doing, and so on. And that's got me wondering whether there's a class of cooperative activities, which even in humans cooperation could emerge. It may even be an advantage if people are not trying to get an overview. They're just, for example, say they have a common purpose. They want to clear up, and they're looking for space in which to have an effect. They have a kind of a selfish motivation to have an effect. And so they're going to end up going to different parts of the mess. And, together they're going to clear up quite effectively. Or, moving a large object, you can't have everybody pushing from the same spot or something like that. But could it be that it's only the spatial differentiation case where, minimal cognition is best?
Yeah, that's great. Yeah. And minimal cognition, I think, does a pretty good job of explaining the group binary search paradigm that we have, where you can just learn without having deep models of intention reading. You can just say, I seem to be doing better, our group seems to be doing better when I just don't react. And it is probably because there's somebody else who's reacting a lot to the feedback. But I think that's very much like the pigeon case that you were talking about. The other case with the Find the Unicorn seems to me to be a little bit challenging, a simple version of that, because it just seems very natural to say, I'm going to be stubborn and I'm going to expect that the other person moves because I'm doing something totally reasonable. I'm going on the right side. As long as my partner can pick up my drift, then they will be able to come up with the left side and we'll be able to do a great job. And so that seems to implicate, especially if they do that fast enough, that seems to implicate them actually thinking about what would be a good policy for both players to be following. But I very much like the idea of seeing continuity for how much intention reading is going on and whether you can end up falling into these roles without having to do much deep thinking about others just because I'm getting good payoffs. I'm not going to overanalyze it. There's a group behavior paper a number of years ago by I think Mike Kearns, where they were doing like group coloring problems. Like you can color any graph with only 4 colors under the requirement that no 2 nodes in the graph can have the same color. You only need 4 colors in order to do that. And they gave a group at the task of finding this coloring. And they found that when you gave people an overview of what the entire graph looked like, Kearns found that they did worse than when they only had their local information. And so that would be maybe an example of what you're talking about the group. When you give the members too much information, they're overthinking things. They end up making larger, more drastic changes to the coloring so that they end up not stabilizing on any consistent coloring.
Beautiful example. Thank you.
Thanks everyone for this discussion, and I would like to open things up for more general questions related to both talks, and maybe I see also some specific questions related to Barbara's talk. But maybe I could start by trying to maybe invite both of you to think about ways to bridge these 2 important pieces of the puzzle that both of you were talking about. So Barbara was talking about communication and when we could know communication is useful, whereas Rob is talking about group specialization and different aspects of it and different mechanisms that go into it. And there are many ways I could see these 2 concepts to be overlapping and informing each other. So for example, when thinking about Barbara's question, it might be the case that, I don't know, communication is especially useful. Maybe I think this is the point that Ishan brought up, is when people are specializing in the sources of information they could bring to the discussion. So people are useful in communicating that when they could bring different pieces of information and combine them together. and that is when maybe the power of communication comes in. And for Rob's, we already kind of touched on this. Communication is a huge part of Carmi framework, and it would be interesting to think about benefits and maybe harms of communication for different tasks. So maybe if you could, in a very free form, improvise on different connections between these concepts as you could see them.
So one thing that I would just point out is, so I like your talk very much, Barbara, and it seems like it's a great response to like Surowiecki, who argues people should always be independent, right? So, which is way too simplistic, and you show great moderating influences of people's calibration and their confidence. But the standard line from Surowiecki is, no, if you introduce any correlations between these separate agents, then you're going to be restricting the variability of the guesses. And so you'll get less of this wisdom of the crowd effect, because rather than, straddling the truth, this is the truth, rather than straddling the truth with your guesses, you're going to have everybody converge together, and you're not going to straddle the truth anymore. So you won't get like people that are too high offsetting the people that are too low. And so I think that your demonstration says that that's too simplistic, and sometimes you're going to get benefits of group process. So sometimes talking is still, even though it does cause this consolidation that you were talking about, you still get benefits. And, when I think about my work on coordination, if instead of like trivial pursuit questions, like, how many people live in Canada, if the questions had actually involved people having to do some research on Google to provide some answer, and there's different components to the answer, then it seems totally clear to me that people would break down into specialized roles. I'm going to find out about, the Canadian political system. I'm going to find out about the Canadian geography, and the group will do better by that specialization, and you'll definitely get the effect that you're not going to do the best when you have completely independent guesses, right? So
yeah, I think I enjoyed your talk very much too. I think one of the intersections is the groups can, maybe if the groups are interacting over time, they're going to learn the specializations of others, and they're going to learn to be quiet when they don't know something relative to group members, and that's really important. That's what often doesn't happen. That makes the discussion just go off the rails. And we did see many discussions go off the rails. The initial estimates were much better than the ones that occurred after discussion. Yeah, there's a social component to specialization that's very important. Do other people know what you know? And that's critical too. I think that optimal group discussions for richer conversations and more complicated predictions, like whether the Russian war will be over in a month, require completely different setups where I think a possible way that might work well is adversarial collaborations of sorts, where people with different positions come together and express the evidence for their side and the lack of evidence for their side, and perhaps reach agreement, perhaps not, but at least have a wider perspective when they make their own estimates.
Yeah, and so in the chat window, Steve was asking about the relatively short-term discussions that were involved in your paradigms, and my feeling was it's probably appropriate given the kinds of questions that you were asking, because there's only so much information that I have to dig into to know what Canada's population is. And I've probably shot my wad within 1 or 2 minutes. But I do think that what you're just talking about, if the questions are more meaty and they're actually going to have more analytic reasoning processes that go in them, and there's different types of resources that you would bring to bear, then I'm betting that you would get more and more of the kind of division of labor that we were looking at.
Yeah, this research project that I talked about came out of the Good Judgment Project, where we had forecasters predicting geopolitical events. And we manipulated whether they were working together or in groups. And some of the groups were just awful. They completely fell apart. And others worked extremely well together. And so, you know, I wanted to understand why this, or whether you could predict such a thing. And that's how it all started. I wanted to say that the super forecasters quite often specialized. Each knew what the other was good at, and they were working very closely within the group, and that specialization was critical. They'd bring it to the group and discuss it. It would, you know, provide lots of different perspectives. So, I love the results you're getting about specialization.
Marta?
Oh, maybe some others are before, but yeah, I really like both talks. Unfortunately, I was late for Barbara's because of another meeting, but Rob, I was really intrigued by this notion of repulsion, like basically, so you understand the roles of the other, the strategies that the other person could play, and then you choose something else. And I was wondering, how would you model that? And I'm sorry if I missed that. Is it based on expected payoffs for me and the other person and the group payoffs? Could you also imagine some other things like social norms, like who should do what in society, kind of shortcuts? There's some interesting things. Also, I mean, relates to Barbara's work, right? Because as far as I understand, I mean, people kind of need to understand who knows what. And could you speculate both a little bit about these mechanisms? Okay, there is some expectation of who knows what, there are norms.
So most concretely, where repulsion comes out in the computational modeling is in the modeling that Edgar did for the Find the Unicorn task. And there it's interesting, the form that the repulsion had to take to fit the human data isn't just a generic repulsion of I'm going to do the complement of whatever I see the other person do on the previous round, but it's very much based upon what you think the person is aiming toward. And that's why like these focal regions are coming into play. So it's the fact that I think the other person is going to a right tile strategy that causes me to switch to the complementary set of tiles going to the left. And so you get sort of contingent repulsion. Then you get repulsion which is based upon your confidence that the other player is adopting a particular policy, a particular strategy. And so I think that's really interesting and important in collective behavior context, because it means that you want people to be somewhat committing to a legible strategy in order to repulse, in order to do the other thing. And so if everybody is sort of like in this chaotic, random kind of strategy, then they're isn't going to be any systematic repulsion possible. So in some ways, we're trying to, I guess, nudge, like I'm thinking like a physical system where there's too high temperature. And so nudging a little bit of into a lower temperature state causes something for the other players to react to. So that's the best kind of computational account that I'm thinking of for repulsion. And I guess the other thing about repulsion, I guess this fits in the multi-level nature of the plans, is that this repulsion is often in the context of higher level synchronization of strategies. So there's a sense in which everybody in like the Battle of the X's is on the same page about trying to take turns in a efficient, a fair, and a stable way. So it's high-level synchronization of goals while also having lower-level specialization into roles based upon if I think on this trial you're going to go for the high payoff, then I'll go for the low. So yeah, so it's an interesting dynamic because it's I guess nested levels of repulsion and synchronization often.
Thank you.
Question. I believe Jim was first to indicate his.
Okay, I'll go quickly. This will be quick. So Barb, this is a question for Barbara. I'm wondering if maybe some of the benefits of these brief conversations might possibly be due to suppression of outliers, because that's one thing you might be able to get in a quick conversation. And this kind of echoes Marina's question about, is there some statistical rule which might mimic the effect of these brief conversations?
Good question. We have, looked for, we have included a number of factors to check the robustness of our results. And one of them is the degree of the outliers, and even taking into effect that the groups with extreme outliers, we still find that collective calibration predicts group improvement.
Well, it'd be interesting to see if outlier judgments are correlated with those confidence or the, but anyway,
Yeah.
so there are lots of fun things that could be done with your data. So
well, we could talk later if you want about that.
Okay. All right. Thanks.
Maybe one more quick question by Arun, if you are still there.
Yeah, sure. So just like I was looking at the larger implications in terms of like future of work, because some of these skills that we learn in school of collaboration could probably apply at workplace, right? So in terms of the transfer in relation to that, and like how could that be made as a training process? I'm not sure if it made sense, but if you'd like more clarification, I can elaborate.
I'm sorry, could you say your question again?
Oh, sure. So from the two talks, I think a broader implication that I see is like in terms of future of work and the skills that can be gained in school, like through education, for example, and this collaborative aspects that you can like train and transferring that to like a workplace environment. So how would that like operationalize with this setup? Is kind of what I'm asking.
So one implication that I see from Barbara's work is that it would help a lot for people to try to figure out for the people in their groups, so more and more of our efforts are going to have to be in group context, and people have to be trying to maybe explicitly try to figure out how well calibrated other people are in their groups, and to know that it doesn't, just because somebody seems confident doesn't mean that they actually are confident. So I think developing deeper intention reading, knowledge reading, interpretations of what people are actually able to do and add to the team, I think is a super important skill. And it connects a little bit with my specialization of roles work, because trying to figure out how people are going to be best used for a particular project is, I think, also super important, and something that people get very little training on in K through 12 school environments.
Yeah, that makes sense.
I think the way in which groups interact is also probably very important and understudied. We had groups talking on the internet and conversations were sequential. It turns out it's really hard to be a big bully when you're chatting, you know, sequentially in a chat room like that. It's too slow, I think. What happens when people are together facing each other? What happens when they're working remotely and, you know, writing their thoughts down? All of that, I think, is going to influence the way in which we interact in groups. And I think there's a lot we need to know.
Excellent. Thanks so much again for the talks and the discussion. This was all super interesting, and I invite people to continue the discussion in the Slack. I will post the chat log there, and we could follow up on people's comments that were not discussed yet. And finally, I would like to invite everyone to our next week's meeting, where David Garcia and Rick Dale will be presenting. I hope to see all of you next week.